Hi everyone, great to see you again. So in this second part of the webinar this afternoon, we will be looking at how to go about developing a real-time distributed denial of service system using Python. So this will be a continuation of what we did in the first webinar, where we developed a real-time, where we developed a machine learning model, which we'll be using in our webinar this afternoon. So for those who haven't seen it, so here is a bit of a recap from what we did last webinar. So in the last webinar, we were developing a real-time denial of service detection system using Python. So in the last webinar, to that end, we created a machine learning model using k-means clustering. So as far as our data set was concerned, we used the NSL KDD cybersecurity data set. And as far as the steps that we did were concerned, we analyzed the data, we performed data preprocessing, we built a model, and then we tested out, and etc. So for our webinar today, we'll be using the model that we created last time in order to detect real-time denial of service attacks. So in this webinar, we will also be discussing how denial of service attacks work, what kind of damage they could cause, and how we could monitor them using Python and machine learning. Okay, so just a bit of a recap. So this was how our data set looked like. So in this case, we have source bytes, where we count the number of bytes that are coming from a particular source, going out of a particular source, and then we also have destination bytes, which counts the total number of bytes that are received at a given destination. We also look into how many total network flows there are, and then we'll be looking at the number of services that are being connected to a particular target. And then we will also be looking at how many common services are there in the destination, as well as we are going to count how many of these network flows belong to the same target, the same source. In other words, we want to know how many of these network tracks that we have discovered can be traced back to a single source. So in this case, these are the 6 features that we are going to be looking at, and then based on the features that we have, then we are going to determine whether or not our target is experiencing a denial of service attack or not. Okay, so just a quick overview. So in building our k-means clustering model, the number of records that we used were a little over 23,000, and the number of features that we used were 6 features, and the different types of attacks that were in the data set were 12 different types of attacks. But for the sake of simplicity in this webinar, we will be looking at whether or not an attack is a network flow is either an attack or normal. So yes, when we train it with 12 different classes, but for the sake of the simplicity for this webinar, we are only going to look at whether or not a network flow is either an attack or it is a normal flow. So there's only like 2 classes. It makes life easier. But when we actually run the course, we will be discussing how to detect all these different types of attacks, because each will have their own different set of characteristics. But for now, we are going to be looking at whether a network flow is either an attack or simply a normal traffic flow. Okay, so a brief overview of clustering. So clustering is a technical term, but in reality, it basically means grouping. So in clustering is a form of machine learning in which we group similar things together, similar features together. So sort of like when you go about in everyday life, we group things together based on common things, don't we? So in this case, we could group people in terms of whether or not they are fans of cricket, whether they are fans of Sachin Tendulkar, or we could also group them in terms of whether or not they are football fans, and if so, we can group them in terms of whether they are Man United fans or Chelsea fans. You get the idea. Okay, so that's how the grouping that we do it in real life. When we apply it in machine learning, it becomes clustering. Okay, so as far as the clustering algorithm is concerned, there are a wide variety of clustering algorithms that we use in data science. But for the sake of our webinar, we'll be looking at k-means clustering. So in this case, the question then becomes, okay, Thomas, so what does k mean? So k basically means the number of groups that we want to create. Okay, so in this example, so we touch upon this in the first webinar, but here is a bit of a recap. So in this case, imagine that we have a collection of these data points, and we want to group these data points into 3 different groups. So in this case, the value of k becomes 3. So in this case, we are going to use k-means like this. So in this case, here's how k-means work. Okay. So in this case, first of all, we are going to assign random center points. So the little x's like the blue x, the red x, and the green x's are what is called the center points. Okay, the center points. And when we start the algorithm, since we have no idea where the center points are going to be, we just assign them randomly. And the whole idea is that if points that are within a certain distance, to each of these points will be classified according to the color. So in this case, out in this diagram now, we will have the first. If we look at this red part of the graph here, you get to see that these 2 points will be classified as the red group because they are close. However, these points will be classified as whether either blue or green. We'll have to see. Okay, but so in this case, this is how it works. So first of all, we assign random points. Okay, so random points on the graph, since we have no idea. And then when we run it the next time, so in this case, points within a certain threshold, certain distance from the center points will be classified accordingly. So as things currently stand, these points are now classified as red because they are closer to the red center point than they are to the green or the blue. And the same can be said for the other groups as well. Okay, so after running it for the first time, what we have to do is we have to recalculate the center points so that they are closer to the points that were classified. So in this case, after recalculating the center points, it will look something like this. Okay, so as things currently stand, so with the red group, so it's now the center of all of the red points, the greens to a certain extent as well. But here we have something interesting here. Okay, so something interesting here. So here we have the blue points, which are fine, but here we have this little point, which is classified as green. However, we can always see using our eyes that it is far closer to blue than it is to green. So in this case, we are going to run our algorithm a second time. So in this case, if everything runs according to plan, then this point will become a blue point. Okay, so let's see if it works. There you go. So in this case, finally, this is how our k-means clustering works. So in this case, when everything is said and done, then we will see that we will have 3 groups. So in this case, we have k. In this case, k is going to be 3. So in this case, we now have 3 groups, each with their respective colored points. So this is how k-means work. Okay, so based on what we did, so as things currently stand, based on what we have done so far, we have used k-means clustering in order to develop a k-means machine learning model that we are going to use in this webinar to detect denial of service attack. So the details of how we went about developing the model we have discussed in detail in the first webinar. So as such, I'm going to go through it fairly quickly over here. So in this case, this is what we got so far. So we have trained, the model that we have trained so far has an accuracy of 97%, which is quite good. Which could be better from a machine learning perspective, but for the purposes of our practical session, it gets the job done, so to say. And it will work. Okay, so with that in mind, let's discuss what we are going to do for this session. So as far as our implementation is concerned, we are going to be using, so in this case, we are going to use our k-means model. So our k-means model we have created as a file. So now in our program code, we are going to simply read the details of the model without having to train it again, which for us is great because we don't have to spend time training the model all over again. We can just use the model that we trained in the first webinar. And then after doing that, we are going to launch denial of service attacks using containers. Okay, so containers. So what containers are, we'll be discussing it fairly shortly. And then we are going to, after that, we are going to monitor network traffic using network logs, and then using those network traffic and the records or the logs that we have created or recorded rather, we are going to determine whether or not our target, or in other words, the machine that we want to protect is suffering from DDoS attacks or not. Okay, so this is what we are going to do for our webinar this afternoon. So first of all, what we are going to do is we are going to load our k-means model. So in this case, what we have done here is from our previous session, we have saved our k-means model as what is called a pickle file in Python. So in this case, all we have to do this time around is we just have to read the details of the model from the file, and we'll be good to go. So in this case, we don't have to spend time all over again in order to train the model over and over again. Look at how denial of service attacks work. So we are going to we're going to be using what is called a container. So so the question then becomes, okay, Thomas, what is a container? And my response to you is a very good question. So containers are what we would call the software versions of computer systems. Okay, so in a normal physical computer systems, as everyone knows, we have a CPU, we have a memory, we have network ports, we have storage and SSD and all the rest of it. However, a container also has essentially is a software version of a physical computer system, meaning that a container consists of its own CPU, its own memory, its own storage space, its own network address, etc. So, in other words, anything that you could do on a physical computer system, you could do it in a container. It is, in other words, a container. For those who have used like software such as Oracle VirtualBox or VMware, for example, you will know what a virtual machine is. Okay, so containers and virtual machines, they all work in the same principle. However, with regards to the containers are much more lightweight than virtual machines. Okay, and so guys, so can you just bear with me a bit? Okay, so, oopsie. All right, guys, so apologies for the technical difficulties because I didn't realize that my face was covering the majority of the slide. So hopefully I fixed it. So hopefully you guys should be able to see the slide's contents now. So as we were discussing, so containers, so what is a container? So containers are essentially software versions of computer systems. Okay, software versions of computer systems. So it has got its own containers. A container has its own CPU, has its own memory, has its own storage space, network ports, and all the rest of it, but they are all implemented in software form. Okay, and not to mention it is far more lightweight than a regular traditional virtual machine, which some of you will have experienced from using software like, say, Oracle VirtualBox or VMware. So for our webinar, we are going to use containers. So in this case, as some of you will know, so when it comes to containers, there are a couple of big names come to mind. So Docker is a well-known example of a container. However, in our case, we'll be using Linux containers. Why? The reason here is very simple. First, Linux container LXC or Linux containers is open source. 2 is free, and 3 it provides a wide variety of Linux distributions that we could use to create containers with. Okay, so to that end, we are going to use a Linux container, which will act as an attacker to launch our denial of service attacks. And our target is going to be an Apache web server running on my own local machine. Okay, so our own local machine. So for the purposes of this webinar, we are not going to cover how to install Apache web server, because if you do a quick Google search, you will get to see a myriad of tutorials on how to set up. So in this case, I'll leave it to you to look into it. But for our purposes, for our webinar, we will be looking at how to use containers to launch attacks. And as far as our denial of service attack tool is concerned, we are going to be using a tool called Slow Loris. Okay, Slow Loris. So Slow Loris is a quick overview of Slow Loris. So Slow Loris is one of the most popular tools that security testers or pen testers use in order to test how strong a web server is against denial of service attacks. Okay, so denial of service attacks, it is quite widely popular and amongst the cybersecurity / pen testing community. And the version and the software and the Slow Loris implementation that we'll be using is available from GitHub. So GitHub, and I will show you the references, the link to the resource in the end. Okay. All right. So before we talk about how to go about launching DOS attacks, we need to discuss what a DOS attack is. And by the way, guys, a bit of a disclaimer: all of the attacks that we will be discussing in this webinar are strictly for educational purposes. Okay. So it's one of those things that we have to make a disclaimer of, because given the nature of cybersecurity tools and the impact and the damage that it could potentially cause if they are not used in the right way, we always need to make sure that we as white hat hackers are using the tools like slow lorries, etc., in the right way. Okay, so because you really don't want to get the police knocking on your door for launching DOS attacks, do you? Okay, so something to keep in mind from a cybersecurity standpoint. All right, so before we talk about the details of slow lorries and launching attacks and all the rest of it, here's how DOS attack works. So imagine that we have a web server here, and then we have an attacker here. So the way it works is, traditionally speaking, whenever we go about visiting a website, say youtube.com or google.com, etc., it typically follows on what is called a TCP three-way handshake. So in this case, in a normal circumstance, the attacker would first send up a sync request, which is the browser's way of saying, hey, hi there. Okay, so that's the first packet that the browser sends. So in this case, the YouTube, after receiving the hi or the sync packet, the web server responds back and sends what is called the syncAC packet, which is, in everyday terms, is their way of saying, hey, what's up? Okay? And then once the attacker has received the syncAC packet from the web server, then the normal user would just send back the acknowledgement packet, and then we start exchanging data between the web server and ourselves. So this is what is called a three-way handshake. Okay, so it starts off with sync and it ends with ACK. So in this case, once the acknowledgement packet has been sent, everything is good. So we start exchanging information, watching videos, sending emails, and all the rest of it. So this is the traditional way of web communication. But in a denial of service attack, however, the attacker still sends the syncAC packet. But after receiving the syncAC packet from the attacker does not send the acknowledgement packet. So the question then becomes, what's the impact? So in this case, without receiving the acknowledgement signal from the attacker, the web server keeps on waiting and waiting and waiting, and in the meantime, there will be other legitimate requests that the web server will be receiving. And for all of those legitimate requests, the web server will say like, hey, I'll deal with you guys in a minute. I'm just waiting for this guy to send me the response back. So it keeps on waiting and waiting and waiting. So over time, the web server becomes unresponsive to the other users. Okay, so to the other users. So as a result, the web server is no longer able to fulfill the service, the responsibilities that it was intended to provide. Okay, so in this case, another way of thinking of denial of service attack is that imagine that you guys, today is Saturday, right? So in this case, you receive a call from your friend, and your friend says like, hey, are you free at 6 o'clock this evening? You say like, I'm free. So let's go. So your friend will say like, hey, let's go and watch a movie at 7 o'clock. So it's like, okay. And you will say like, yeah, it's okay, no problem. Let's watch a movie at 7 o'clock then. So your friend will say like, okay, I'll call you again at 7 o'clock to confirm. So it's like, no problem. So you keep on waiting and waiting, and in the meantime, you have other friends asking you to go watch another movie with them at the same time as well. So you said, but since you're given your promise to the other friend, you tell your other friends, I know I need to go with, Roshan, and I've already got an appointment with Roshan, so I couldn't meet you guys. Maybe some other time. And 7 o'clock come around, you keep on waiting. In the meantime, you still have other friends because you have a lot of friends. So other friends keep on asking you to come and watch movie with them, but still keep on waiting and waiting and waiting. And then 9 o'clock comes around, and you say, like, you know what? This guy's not gonna come today. So in this case, what happened? So in this case, you end up not being able to go to the movie, not just with Roshan in this case, but with other friends as well. So this is how, so that concept, when applied in security context, it becomes a denial of service attack. Okay, so hopefully that makes sense. So in this case, so this is what this is the form of attack that we'll be looking at for our webinar today. So the question then becomes, what is the impact of a denial of service attack? So as the name suggests, so by making a lot of unfulfilled requests, you kind of prevent the web server from providing services to other legitimate users. So from a business perspective, it kind of it reduces a lot of money because you couldn't provide services to legitimate customers. And for our webinar today, we'll be looking at how to go about detecting these kind of attacks using containers. So we already discussed containers before, but here is an overview of what containers are. So containers are software versions of computers. So they essentially, we could use containers in the same way as we could with normal physical computers, or to a certain extent, virtual machines, but they are far more lightweight and easier to use. So with that in mind, that's what we'll be looking at for our webinar. So as things currently stand, so here's what the setup looks like. So what I've done here is I have installed Apache web server on my native local machine. We are going to specify what is called a sleep time of 2 seconds. Why the sleep time, Thomas, you might be asking. So sleep time is basically that, yes, we are going to send like 5 million packets to our web server. It will guarantee to crash for sure. But in this case, rather than sending 5 million packets all at the same time, what we want to do is we want to pause it, send it again, pause it, send it again, in order to avoid being detected. So be detected by whom? Detected by the network intrusion detection systems that are able to detect these attacks. So in this case, if we as an attacker are sending all these packets, 5 million packets from a single machine, then it would be quite easy for the IDS, or the network intrusion detection systems, to detect them. So in order to avoid detection, we are going to send it once every 2 seconds. So in this case, we are going to send it, and then we are going to wait for 2 seconds. And then after 2 seconds, we are going to send it again, and then we are going to wait again, so on and so forth. You get the idea. Avoid detection. So that's what we'll be doing. And then in the meantime, from a security standpoint, what we are going to do is we are going to monitor the network traffic that is going on between our target and the attacker. So more specifically, we'll be looking at a couple four key pieces of information from the network flows. Namely, we are going to be looking at the source IP address, the IP addresses coming from the IP address, the source IP address, the destination IP address. In addition to that, we will also be looking at monitoring the source port or the source service number and the destination port or destination service numbers. So before we move on, I'd like to give a quick overview of what I meant by port or service. Some of you will have a clear idea of what these port numbers or services are, but for those who don't know, here is a brief overview of what I meant by services and port numbers. So when we look at different services that are internet based, so in this case on the internet we have a lot of different services that are using the internet to provide services, right? So services like Spotify, for example, we have YouTube, etc., and web servers, so for sure. And each of these services have their own service ports. They run on particular service port numbers. So by having port numbers for each different service, we are able to provide different connections to different services. So for example, port 8 HTTP server, or in other words, a normal web server, runs on port 80. And by the same token, SSH, which is used for remotely connecting to a server or a machine on the cloud or a remote machine, runs on port 22, so on and so forth. So each of these services that are run on the internet have their own specific port and service numbers to distinguish themselves from other services. And at any particular given point in time, one machine will be connected to a myriad of services. Like for example, at any given point in time, you guys will be connected to WhatsApp, for example, and Spotify, right? Chrome, of course, Fiber, and each of these services will have their own ports. So what we are going to do for the purposes of our webinar is we are going to monitor the HTTP service flows. Okay, so service flows. And for more details of the port numbers, a comprehensive list of the port numbers, you can check it out on the IANA website. So I will provide the references before we move on to the practical session. Okay, so in this case, just to give everyone a bit of a flavor on what I meant by network traffic flow, here's what I meant. So here we have a screenshot of the network traffic flow. So as everyone can see, the ones in the red are the IP address of our target machine, target web server rather. So in this case, we have 10.105.28.1, which, if you guys remember, is our target's IP address. And if you look at this diagram, look at this screenshot here, you get to see that we have a lot of common. We have 10.105.28.36. Quite common, isn't it? So what does it tell us? So it basically tells us that from a security standpoint, this is going to be the attacker's IP address. Hopefully this makes sense. So in this case, here we have the source IP address for this example. So this flow, this network traffic is coming from the attacker's IP address, which is coming from a dynamically specified, dynamically obtained port number, port address. And then the target here is going to be our target, and it is targeting port 80 of our target, which, as we previously discovered, is going to be the HTTP port number, and the amount of bytes that is sent is 85 bytes. Okay, so as you can see, so we have the target IP address, and then we have the source IP address, destination IP address, source port, destination port, and the size of the packet, size of the packet. So and as you can see, so if you look at all of the traffic flows coming from the attacker, you get to see that the port numbers are not tend to change. Okay, they tend to change in general, and it makes sense because if we, from an attacker's perspective, if we send packets from a same source port, then it makes things easier for the intrusion detection system to detect. So in order to avoid detection, not only are we going to change the frequency with which we send the traffic, but we are also going to change the port through which we are going to send these malicious packets. So in other words, we are going to make life as difficult for the security analysts or the cybersecurity researchers in order to detect them. Okay, so hopefully this makes sense. And then, so now we are going to look into the detection side of things. So once we've got everything set up, then we are going to monitor the network logs once every 2 seconds. Okay, so we could monitor every single second if we want to. We could monitor once every 30 seconds if we want to as well. But based on our experience, for the purposes of our webinar, we are going to monitor once every 2 seconds. Because why? Because we know that we are going to launch attacks once every 2 seconds. So that's why we are going to monitor our attacks once every 2 seconds as well. Okay, so in a real life environment, it depends. So the frequency of monitoring will depend on the amount of computing resources that you have, as well as the typical frequency of a DDoS attack. But in a real world scenario, we would try to monitor once every 15 seconds, for example. We'd be a bit longer. But for the purposes of our webinar, we are going to monitor once every 2 seconds. Okay? And when everything is said and done, when we actually run it, which we'll be running very, very shortly, this is what we'll be seeing. So in this case, we are going to see the total number of packets that we have obtained. Total number of packets that we have obtained. And then out of these, we are going to differentiate how many of these packets are normal and how many of these packets are attacks. Okay, so this is what we'll be looking at after everything, once we have started running the entire attack and the detection side of things. Okay, all right, so for the webinar today, we'll be looking, the Python tools that we'll be using are going to be our good old friend pandas, which we all know from our first webinar, is used for reading large data sets. And in addition to that, we'll be using something called PyShark. So for some of you will have experience with Wireshark before, but PyShark works in the same way as Wireshark, and it is used for monitoring and analyzing network traffic. Okay, so network traffic. And then last but not least, we are going to be using scikit-learn for building and reading machine learning model, and in other words, to classify whether or not the network flows are either normal or attack. Okay. All right. So before we move on to the practical session, here are the references that I have mentioned in my slides just now. Okay. So the slow logic source code, you can get it from GitHub, which was developed by Goldberg Yatiraki. Okay, and then the list of ports, comprehensive list of ports, can be obtained from the IANA website. Okay, so with that said, let's move on to our practical session. Right. Right, so in this case, so what I've done here is I have got 2 terminals running. Okay, so I have two terminals running. So the first terminal is for the detection for running our detector script, and the second tab is the is the container. So this is where we are going to run our container. And then here we are going to run our attack detector. But before we do that, so now since we have already seen how the attacks are, how the results are going to be, how we are going to run the attacks, so on and so forth, let's have a look at the code to see how we have implemented this. Okay, so with that said, here is the Python script that we have created in order to detect denial of service attacks. So first of all, we have the usual shebang. This is what is called shebang, by the way. And here is going to be, first of all, we are going to import PyShark. Okay, so PyShark, as we mentioned just now, is used for monitoring, is used for analyzing and monitoring network traffic. And we are going to import a module called net interfaces, which is used for obtaining network interfaces that are available on the host, so that we could use it to capture packets. And we are going to import CSV as well. So the CSV module is for reading and writing CSV files, which we will be using in order to record network flows. And then we already know what pandas is. So pandas is used for reading and writing large data sets. Import pickle, so we are going to use pickle for reading our machine learning model. Datetime, self-explanatory, which is used for recording time. And then we are going to use the concurrent.future, which is an interface or a package that we will be using for running concurrent programs. Okay, so concurrent programs asynchronously. And then, since we are going to be using k-means clustering, so in this case we are going to be using the k-means module from scikit-learn. So these three packages we have discussed it in our first webinar. So we really don't need to go through that in detail. So as far as our tools are concerned, these are the packages that we are going to be using for our code. Okay, so in order to first understand it, we need to go to the main function. So whenever we go about analyzing or understanding a program, the first entry point is always going to be the main function. So the main is the main entry point, so to say, that where all of the entire program starts. So first of all, what we are going to do is, before we run it, before we go about detecting DOS attacks. So first of all, we need to select the interface on which we are going to monitor network traffic. So in this case, we are going to first get all network interfaces that are available on our local machine. And then once we have collected all of the different network interfaces on our local machine, then we are going to ask the user to select the interface on which we are going to monitor our network traffic. Okay, so in this case, we are going to measure it, provide the name of the network interface, and then once the user has provided the name of the network interface, so in this case, what we are going to do is, as long as while true, what does it mean? So as long as the program is running, what we are going to do is we are going to perform network packet capturing. In other words, we are going to capture the network traffic from the network interface that we have specified previously, and then we are going to determine whether our target is suffering from either a normal traffic or a possible DDoS attack or possible DOS attack. So in this case, the question then becomes, what does this function do? So in order to do that, we need to go to this function. There we go. So in this case, in this function called packet cap. So we are going to capture our network traffic, live network packets once every 2 seconds. Okay, so once every 2 seconds, and then after every 2 seconds, what we are going to do next is on all of the packets that we have captured, we are going to apply the function called extract information. So as the name suggests, we are going to extract all of the features that we have discussed just now. Okay, early on in our webinar, in order to extract all of the information that we need in order to detect DOS or denial of service attacks presence. So, and then once we have extracted the information that we need, then we are going to perform calculation. Okay, so in this case, what kind of information we are going to extract? So let's look at this function. Okay, so in this case, in this extract method, in this extract info function, we are going to extract 5 key pieces of information. So first of all, we are going to extract packet length, which essentially is the size of the packet that we have received. And then we are going to extract the source IP address, the source port number, the destination IP address, which is the destination IP address, and then we are going to extract the destination port number. Okay, so as far as extracting info is concerned, we will be extracting these key pieces of information. So in this case, into this packet length variable, we are going to get the size of the packet, which we could obtain using pkt.length. Put it in here. We are going to extract the source IP address, put it in this variable. You get the idea. And then once we have extracted all of this information, then what we are going to do is we are going to create a file called csv_capture.csv. Okay, so we are going to open up a CSV file to write all of these data in. And notice that we have put it a flag called add additional records into it. Okay, so we are going to add additional records into it. So that's what append is. So append basically means that if there's no new file there, then no problem. We are going to create a new file. However, if the file is already there, we are going to write at the end of the file. Okay, so end of the file, editing, in other words. So once we have created the file, so what we are going to do is we are going to write everything, all of the information that we have extracted into the file, and then we close it. So that's what extract information does. So basically, extract information is all about extracting the information, like the packet length, source IP, source port, destination IP, destination port, and simply writing them into a CSV file. Okay, and the method that allows us to do this in the CSV module is the method called the writer. As the name suggests, allows us to write to a CSV file. Okay. Once we have extracted all of our information that we need in order to detect our attacks, so the next function that we'll be running is going to be calculate features. So as the name suggests, we are going to start our packet statistics calculation. So in other words, in this function, we are going to use data science in order to calculate the features and by extension detect presence of denial of service attack. Okay, so let's have a look at what this function does. Okay, so in calculate features, so in this calculate features function, we are going to use our good old friend pandas in order to read the CSV file called CSV_capture that we have previously created. And as we all know, it contains all of the details of the source IP address, the size of the packet, so on and so forth. Okay, so we are going to read through it, and then what we are going to do is we are going to read the contents of the CSV file line by line. Okay, so line by line. This is what iter rows does. Iter rows basically means iterate rows. So in this case, a CSV file is sort of like an Excel file where all the records are stored in rows. So by using this function, Python will be reading the records line by line. Okay, so line by line. So for each of the rows in this function, so we are going to get a line here, and then we are going to extract the each of the variables from each of the information that we have written into their respective values, respective variables. So in this case, we are going to assign. So the first value, the first entry in the CSV is going to be the size of the packet. So as such, value 0 will be assigned into the current length variable. The second value will be into the source IP address. The third value, so on and so forth. Okay. And then next up, what we are going to do is we are going to calculate the statistics that we have mentioned, we have discussed early on in the webinar today, as well as in our webinar last week, whereby we are going to calculate the total number of packets. We are going to calculate the total number of bytes, right, that are being received from a particular source, and then we are going to count the number of services that are the number of flows with the same service. Okay, and then we are going to count the number of flows with the same destination. Okay, so the same destination, and last but not least, we are going to count the number of packets containing the same host and the same service from the destination IP address. Okay, so in other words, once we are able to calculate them, then we are able to start our detection. So now that we have assigned it to the variables, now we are going to start calculating. We are going to start calculating our statistics. So in this case, we run our loop one more time, once again over our CSV file one more time. We did exactly the same as well. So in this case, what we are going to do is, if the source IP address is the same as, if we are able to find the IP addresses are the same and the destination IP addresses are the same as well. So in other words, for a given network traffic, given network flow, if the source IP address and the destination IP addresses are the same, then what we are going to do is we are going to increase the number of traffic flows by 1. Okay, so by 1, and at the same time, we are going to add the total number of bytes that are received. Okay, so that are received at the source into the variable called source bytes. Okay, so in this case, if the source IP address, and the destination IP addresses are the same, then we are going to increase the count by 1, and at the same time, we are also going to add the total number of bytes that are received at the source. If that's not the case, then we are simply going to get on with our life, basically. That's what it means by pass. It basically means continue. And by the same token, if the source port is the same. So if the source port for a given port, given network flow is the same as the port that we have identified, then we are going to increase the number of services or service count by 1. Okay, so by 1. So far so good. So far we are able to identify 3 variables. So we are able to identify 3 variables, and then we have 2 more variables to go. So finally, so this is for the source side of things. So now we are going to look at the destination side of things. So as far as these are concerned, these are more related to the source side of things. And however, now we are moving on to the destination side of things. Okay, so in this case, as you can see, if we are able to find if the destination IP addresses are if both the destination IP address and the destination port are the same, we are able to identify that the destination IP address as well as the destination port numbers are the same in the given throughout the CSV file, then we are going to increase the destination host service count by 1. Okay, so in other words, if we found that a given destination is receiving a lot of network traffic at a given port number, then we are going to increase the destination service count by 1. Okay, so destination service count by 1, and by the same token, if we found that a given source is sending a lot of network traffic on a given port number, then we are going to increase it as well. And as well as we are going to add the number of packets as well. And then last but not least, we are going to count how many of these packets are coming from the detection that is responsible for detecting our text is going to be this function called machinelearn. Okay, so now that everything is said and done, we are now ready to detect a text. So the first thing that we are going to do is we are going to read our packet statistics file by using our good old friend pandas. Okay, by using the read_CSV function of pandas. So by using this function, we are going to read our packet statistics file. Okay, so if we couldn't read the file, so in this case, we will say the data is empty, which is more of a fail-safe mechanism than anything. Okay, fail-safe mechanism than anything, but in reality, we don't really need to worry about it. Okay, so really need to worry about it. So if we are able to find content, which we will be, okay, so which we will be, and then, so in this case, else. So in this case, the first step is going to be, before we go about detecting them, the first thing that we need to do is encode feature. So the question then becomes, why do we need to encode the features? So the reason why we have to encode the feature here is very simple. So if you remember our first webinar, when we trained our K-means machine learning model, the first thing that we did was to scale the model, scale the entries in the model to be between 0 and 1. Why? Because we didn't want, so in order to make sure that, in order to improve accuracy and to make sure that the representation of all of the features are normally distributed. Okay, are normally distributed. So since we did it when we train our model, we need to do the same before we use our features to detect them. Okay, so in our encode feature, so what we are going to do is we are going to read our CSV file using pandas function, and then what we are going to do is we are going to use scikit-learn's preprocessing module using the standard scalars function in order to scale our features to be between 0 and 1, so that the machine so that we are able, so that our k-means machine learning model is able to detect them accurately. Okay, so so essentially, encoding features is something that we need to do from a data science perspective in order to improve accuracy. Okay, so improve accuracy. So now, once we have done it, so in this case, the data is ready to be, excuse me, so the data is ready to be classified. So, and then next step is going to be step 3. So in step 3, we are going to load our k-means model. K-means model, so excuse me. So in this case, so now that we have read our data set, our packet statistics, now that we have scaled our features, the data is ready to be classified. So now it's time for us to load our k-means model. So in order to do that, we are going to use the load function, the load method of the pickle module. So in this case, we are going to read our k-means model, the same model that we created in our first webinar, and then we are going to read it in read bytes. So RB stands for read bytes. Okay, so RB means read bytes. Okay, so read bytes. And then, so in this case, after reading the model, so the model is ready. Okay, so the model is ready, and so are the data. So now, in order to predict them, all we really need to do is call the predict method. Okay, so predict method of the k-means module, and then into the argument, we simply pass our scale data. That's it. So really, so in this case, finally, so we are going to perform attack prediction. So in order to make predictions, we are going to use k-means.predict, and we pass our data, and then from this function we are going to get a set of predictions. Okay, set of predictions. So as far as our predictions are concerned, if we remember our first webinar, you'll get to see that there are a wide variety of attacks in the data set. However, for the simplicity of our webinar this week, we are simply going to classify as whether or not a network flow is either an attack or a normal. So we only have two. It's 1 or 0. Excuse me. So 1 or 0. So if 1 means attack, so 0 would be normal. Okay, so 0 for normal, 1 for attack. Makes life easier. Okay, so in this case, what we are going to do is, from this prediction, we will get to see 1s and 0s. So in this case, what we want to do is we want to know how many network flows are normal, how many network flows are attacks. So in this case, so now that we have got the predictions. So in this case, what we are going to do is it's an attack. So if it is an attack, then we are going to add 1 to the number of attacks. Otherwise, we are going to add 1 to the number of normal traffic. Okay, so in this case, from the predictions, we are going to check how many of them are attacks and how many of them are normal. So after checking it, we have to know, we want to know, right? So in this case, we are simply going to print. Simply going to print the number of normal traffic, and then we are going to print out the number of normal attack, the number of attack. Okay, so it's fairly straightforward. So to summarize, in order to detect attacks, first step 1, capture traffic, right? So capture traffic. Step 2, calculate packet statistics. Step 3, scale the feature statistics. Step 4, predict attacks. And step 5, count the number of normal and attack network flows. Okay, so it is a 5-step process. Okay, so when everything is said and done, so what we are going to do is, so in this case, so what we are going to do is, This is just for more of a from an analysis perspective. Okay, so as far as detecting the attacks are concerned, it basically ends here. However, as we all know, so when from a security standpoint, we want to know exact detail. We want to know how the attacks work and etc. So in this case, what we are going to do is, we want to know. So in this case, if the number of attacks. So in this case, if the number of attacks is the total number of attacks is greater than or equal to half of all of the total number of network packets that we have captured. So in other words, if more than 50% of the network flows are classified as attack, then we really need to be careful now. We really need to take action from a security standpoint. So as such, we want to write to a log file called log.txt, and then into the log.txt file, we are going to write attack detected, and then we are going to write the date and the year, month, and the day, as well as the time and the minute at which the attack was discovered. Okay, so attack was discovered. And then not to mention, we are going to write, not only are we going to display this on the screen, but we are also going to write the same content into our log file as well, so that we could use it for later purposes. Because from a security standpoint, we need to have records of everything. That's a hallmark of a good cybersecurity professional. Okay. And then the same goes as well. So if it is an attack, then we are going to write attack detected along with the date and time and the rest of it. In other words, the timestamp. Otherwise, we are just simply going to write. Now it's just normal. Nope, no, don't worry about it. Okay, so otherwise, if neither of them were true, so in this case, otherwise we just leave it be. Okay, so hopefully, so in this case, this is a five-step process to detecting denial of service attack. Okay, so now that we have understood how the code works, so let's look at how we actually run it. Okay. All right. So here we have two terminals as we discussed. So here we are going to run our packet track, our DOS attack detection system, and here is when we are going to run our container. So the first thing that we need to do is, in order to run it, we need to type in sudo python 2.7 attack detector.py. So you might be asking, why, Thomas? Why Python 2.7? The reason is very simple, because as of this recording, the PyShark module is only compatible with Python 2.7. So in the future, it will be compatible with, there will be efforts to update PyShark to be compatible with Python 3, which is now the industry recognized. But as things currently stand, this is how it goes. So in this case, sudo packet python 2.7 attack detector.py. So another point that is worth mentioning is, why sudo? The reason here is very simple. In this case, we are trying to get access into the underlying network card. So in Linux, access to the underlying hardware is only available to the root user, and it's not available to a normal user. So in order for us to get access to the underlying network interface, we need to run it as sudo. Okay, so run it as sudo. So that's why we are running our program as sudo python 2.7 attack detector.py. Okay, so first of all, we are going to run our attack detector.py script. So enter. Okay, so as things currently stand, it will show us all the the network interfaces that we have at our disposal. And the interface that we want to capture our network interface from is going to be LXDBR0, which is where our containers web interface runs. So in this case, it would be LXDBR0. Okay, so we are ready to go. But in order for us to detect it, so in order to do that, we are going to run our Python attacker slow lorries Python script. Okay, so in order to do that, we are going to run Python 3, the name of our script, which would be slowlorries.py, and our target IP address is going to be 10.105.28.1. The number of sockets, the number of packets that we want to send is going to be 5 million, which is quite huge, I would say. And then the sleep time is, in other words, the amount of time that we want to rest, we want our script to rest, is going to be 1 second. It's a bit too extreme, but this is how it works in real time. Okay, so in this case, Python 3, slowlorries.py, our target IP address, the number of sockets that we want to send, and then the amount of sleep time that we want to specify. So with that said, we are going to start launching our attacks right about now. So now it has started launching attacks. So in this case, now we are going to start our detection here. So press enter. Let's wait a bit. So as you guys can see here, based on our detection, we are now able to identify the number of packets that are potentially attacks. So as things currently stand, here we have, so in this case, for example, we have a total number of network packets. So in this case, we have a total number of 213 packets. However, out of them, we have 366 of them, in this case, out of them, 115 of them are normal packets. And here we have, okay, so in this case, so as you guys can see, we are able to detect the presence of DOS attacks on our target. So you might be wondering why, Thomas. So in some cases, the number of normal packets are okay, but in some of the cases, the normal packets, the number of attack packets are low. In certain situations, the number of attack packets are quite high. The reason here is very, very simple. The reason why it is the way it is that slow lorries operates based on a randomized manner, meaning that whenever we, just like we said, so although we specify like 5 million packets, the way slow lorries works is that it will not send 5 million packets all at the same time. So in 1 second, slow lorries will send, like, say, 40,000 packets, for example. And then it will just wait for 1 second. And in the second time around, it will send like 1 million packets. It rests again. In the third time, it will send, like, say, 300 packets. And then it rests again. So the number, although we have specified that we want it to send up to 5 million packets, it will send the number of packets that it will send at each interval will be randomized. Why, you may be asking? The reason here is very simple. It's simply to avoid detection. It's simply to avoid detection. That's it. Because because back in the day, DDoS attacks were quite successful because the network intrusion detection systems at that time were quite robotic. But now, with modern technology, modern developments in machine learning and etc., network intrusion detection systems have become really, really clever. So really, really clever. So it's not hard. It's no longer difficult for a modern intrusion detection system to detect a constant stream of DOS attacks. So in order to avoid detection, from a attacker perspective, we need to randomize the total number of packets that are sent at any given point in time, in order to throw off the network intrusion detection system's ability to detect our target. Okay, so as far as we are concerned, so this is how we go about detecting denial of service attacks using Python and machine learning, along with data science. And this is one of the many topics. So this is one of the many topics that we will be looking at. We will be looking at for our Python for data science and cybersecurity course from CreArt. So here is an outline of what we'll be looking at in our course. So in this case, so we will start. So as you can see, we designed this course with in order to help those regardless of your pre-existing programming experience. It is designed to be friendly for both those who have no prior programming experience as well as those who have a basic understanding of programming and by extension Python programming. So as you can see in the course content, the first few weeks we will start things slow. So we are going to look into the fundamentals of Python programming. We'll be looking at data structures in Python, functions and methods. So we are going to basically start looking into the basics of Python programming. And then once we have completed the basics of it, we will be looking into the fundamentals of data science, which is where we'll be starting our look into the basic data science, like descriptive data analytics, which is where we look at what mean, median, mode, standard deviation, percentiles, quartiles, and more specifically, we'll be looking at how we go about interpreting them. Right, so in this case, as far as Python is concerned, Python has a huge collection of data science libraries that we could use. However, the main difference lies in the fact of how we go about interpreting them, how to go about writing programs, how to go about understanding what the numbers are. Okay, so we'll be looking then in weeks 3 and 4, we'll be looking into fundamental data science. And then once we start in week 5, we start our more in-depth look into data science, which is where we'll be looking into using pandas for data analytics. And then starting from week 6, we are going to start our descent into time series analysis, which is where we are going to analyze things like stock market fluctuations, stock market predictions, so on and so forth. And then we will be looking into linear regression in week 7. And then starting from week 8, we are going to start our more detailed look into machine learning and how they are used in a cybersecurity context, starting with clustering, which was the topic of our webinar. So in this case, we are going to discuss more in depth into what clustering is, how we could use clustering, the different applications of clustering, and not to mention how we could use clustering to detect not just DOS attacks, but how to detect malware attacks, how to go about detecting buffer overflow attacks, so on and so forth. And then we will also be looking into other machine learning models, such as support vector machines, naive Bayes, and we will also be looking at more modern machine learning techniques, such as deep learning, using PyTorch. Okay, so PyTorch. So we will be looking at all. So and as you can see, as far as the content is concerned, each of our weekly sessions is accompanied with a mini project that allows you to practice what we have discussed, and then at the beginning of each session we have a quick discussion on what we did, your experience with the mini project, any areas that need further explanation, so on and so forth. So by doing that, the way that we have structured our content is more of a student-centered approach, which is where we want to make sure that you guys have the fundamental understanding of all of the topics that we've been discussing, as well as giving you the opportunity to practice and discuss and experiment and get a hands-on experience. And then we will also provide feedback as well. So as far as the content, so in this is a 12-week program, and this is how we have structured it. So it would be great to see you all. And normally, given the nature of the topic, given the nature of the content that we'll be covering on this course, in the normal circumstances, in normal typical training course, in normal typical training environment, courses like this will typically go for around like £6,000 minimum, and that is true for most, if not all of the training schools here in the UK. But in our case, we are more aware of you guys. We want to cater more for you guys, and we understand where you guys are coming from. And with that in mind, we are willing to offer this course at a much lower price than than other training institutions, and we also provide opportunities for scholarships as well. So if you guys are interested in it, please feel free to register. Please feel free to log on to please register your interests at crearteducation.com, and here is the link here. So crearteducation.com, and under crearteducation.com, click enroll now, and you can click on book my seat, and you are more than you can register yourself here. Okay, and if you guys are for those who are interested in our course, you can also book a one-to-one session with us to discuss the details of our course and and register a one-to-one session with a one-to-one online session with us on the link provided in the description. So as far as our course from CreArt is concerned, we we not only aim to provide a real hands-on Python programming experience to you guys at a reasonable price, we also aim to help you provide to assist you in your career planning, in you getting a technical position with the amongst the technical companies, both in the UK as well as internationally as well. So if you guys are interested, please feel free to book a one-to-one session with us in the link provided in the description. And please, if you are interested in the course, please feel free to register your interest at crearteducation.com. So with that in mind, it's been a pleasure sharing my expertise and my experience in data science, in cybersecurity with you all, and I hope to see you all soon on the course. Bye.